All right, in 8.7, we are going to be looking at product to sum and sum to product formulas. So on the packet that I uploaded into that place, Canvas, it's on page 3, and you'll want to look at the bottom and notice we're going to use these when your arguments don't match, when we're using different angle measures. And sometimes it'll give us nice, pretty benchmark angles that we can actually utilize to get ratios. Sometimes it won't. But we've got product to sum. So if I've got a product, so sine of an angle times the sine of a different angle, I'm going to apply this formula. And then same thing, it goes all the way down if we're going to be adding or subtracting functions. So I can add two different sines together. I can subtract sines, add cosines, subtract cosines. So literally, this video is going to be a little bit longer simply because I'm not going to make two of them because it's pretty straightforward. So actually, this may be one of the easiest sections in the course. So hang on, back this up. So I've got the sine of 195, which is not a benchmark angle. And I'm going to multiply that times the cosine of 105, which is not a benchmark angle. So when I look at this, I notice that it's a multiplication of sine alpha times cosine beta. So sine alpha times cosine beta, if this is my alpha and if this is my beta, then I'm going to apply this formula. So I get 1/2 times the sine of alpha plus beta plus the sine of alpha minus beta. Okay, so what does that give us? We will have 1/2 times the sine of 195 plus 105 plus the sine of 195 minus 105. So doing some math that we know how to do, 195 and 105 gives us 300. And 195 minus 105 gives us 90, and those are benchmark angles. So we can find the sine of 300, and that is going to be the same thing as the sine of 5 pi over 3, which is going to be a negative root 3 over 2, plus what's the sine of 90 degrees? That's 1. So I'm going to get a common denominator. So I'll have negative root 3 over 2 plus 2 over 2. And then my common denominator is 2, but I'm going to multiply it by this 2. So I'll get a negative root 3 plus 2 over 4. So that's actually, when you multiply these two ratios together, that's what you would get. Okay, so let's try another one. We've got the sine of 135. And that's going to be times the sine of 15. So 135 is a benchmark angle, but 15 is not. And I'm not going to go into half angles. I'm not going to do all that kind of stuff. Why? Because I know how to represent sine alpha times sine beta. So I'm going to use this formula. So I've got 1/2 times this, oops, sorry. That is so not what I have. I have alpha and beta. So I've got 1/2 times the cosine of alpha minus beta minus the cosine of alpha plus beta. Okay, so what are my alphas and my betas? I've got the cosine of 135 minus 15 minus the cosine of 135 plus 15. Well, 135 minus 15 is 120, which is a benchmark angle. And then 135 plus 15 is 150, which is a benchmark angle. So the cosine of 120 is going to be negative 1/2 minus the cosine of 150 is going to be negative root 3 over 2. So that turns into plus positive. Your common denominator is 2, but we're going to multiply that by this 2, so we're going to get a 4. So we got negative 1 plus root 3. And those are your ratios. So let's do a couple more. Wrong page. All right, so I've got sine of 8 theta times the sine of 5 theta. So I notice it's sine alpha, you can't see. Sine alpha, sine beta. So using the appropriate formula, I've got 1/2 times the cosine of alpha minus beta minus the cosine of alpha plus beta. And so substitute in, and we'll have the cosine of 8 thetas minus 5 thetas is 3 thetas, minus the cosine of alpha plus beta, or 8 thetas plus 5 thetas, is 13 thetas. And that's really as far as you can go. Make sure you're not reading these as zeros. These are thetas. Okay, so that's not the cosine of 30 and the cosine of 130. 3 theta, 13 theta. Okay, so let's try another one. We've got the sine of 8 theta times the cosine of 2 theta. Okay, so again, I'm going to look for sine alpha, cosine beta, and use this formula. So that gives me 1/2 times the sine of alpha plus beta plus the sine of alpha minus beta. So if this is my alpha and if this is my beta, what I have is 1/2 times the sine of 8 thetas plus 2 thetas is 10 thetas, and then plus the sine of alpha minus beta, 8 thetas minus 2 thetas is 6 thetas, and that's really as far as you can go, because we just gave you multiples of some unknown. So you can't go really any further with these. Okay, so let's do the cosine of 2 theta times the cosine of 5 theta. So I'm going to look for a cosine alpha, cosine beta. So my formula is 1/2 times the cosine of alpha minus beta plus the cosine of alpha plus beta. So this is my alpha and that's my beta. So I've got 1/2 times the cosine of 2 thetas minus 5 thetas is -3 thetas, plus the cosine of alpha plus beta is going to be 7 theta. Now hang on a second, because you're not done. Your argument just went negative, and you know how to handle a negative argument because you learned all about even and odd functions. So when I'm looking at this, cosine is an even function, which means it doesn't matter if my angle measure is positive or negative, it will spit out the same ratio. Okay, so I can actually ignore that negative. So my final answer is going to be the cosine of 3 theta plus the cosine of 7 theta with a 1/2 out front. Okay, so now let's do one more. Let's flip pages. I'm kind of going fast because this has been a really tedious chapter, and these ones are pretty straightforward. So I'm trying to squish it all into one simple video, which looks like I'm going to be able to do. All right, so I've got the sine of 15 theta, and then times the sine of 16 theta. So I'm looking for sine alpha times sine beta. So sine alpha, wrong page, sine alpha times sine beta equals this formula. So that's what I'm going to apply. So I've got 1/2 times the cosine of alpha minus beta minus the cosine of alpha plus beta. So 1/2 times the cosine of subtract yours, so I get a negative theta, minus the cosine of add these, I get 31 theta. But again, watch out. You got a negative argument. Cosine is even, so a negative angle and a positive angle will give you the same ratio. So I can essentially ignore that negative. Whoops. There. Hard brackets. Okay, doesn't matter. You can use hard brackets or soft brackets. All right, so what happens if we flip-flop this thing? So let's look at the sine of 8 theta minus the sine of 2 theta. Well, now I've got addition, subtraction. So am I going to have to work backwards and find all this? And what did I subtract and what did I add to get to these numbers and all this kind of stuff? No, no. Look, you got sine alpha minus sine beta. And so I can just apply it into this formula. So my alpha and my beta, and I'm going to apply it into 2 sine alpha minus beta over 2. And then I'm going to do cosine of alpha plus beta over 2. So I've got 2 times the sine of alpha minus, so 8 thetas minus 2 thetas is 6 thetas over 2, times the cosine of 8 thetas plus 2 thetas is 10 thetas over 2, and I can reduce that. So 2 times the sine of 3 theta times the cosine of 5 theta. And that's it. That's all you can do. So let's do a couple more. I've got, not enough room, cosine 5 theta plus the cosine of 7 theta is going to be cosine plus cosine of different angle measures. If these were the same angle measures, you would combine them and say 2 cosines of that angle measure. Okay? But you're not going to do that. And then similarly, if you had been multiplying here and these were the same angle measures, if your arguments matched, you would get sine squared. But that's not what we have. So that's not what we're doing. All right, so cosine alpha plus cosine beta means I will have 2 cosine of alpha plus beta over 2. That was a lovely alpha. And then the cosine of alpha minus beta over 2. So my 2's can look like alphas. Sorry. So this is alpha and this is beta. So when I sub in, I'm going to get 2 times the cosine of add these things. So 5 thetas and 7 thetas is 12 thetas over 2 times the cosine of alpha minus beta. So 5 thetas minus 7 thetas is negative 2 thetas over 2. So that gives me 2 times the cosine of 6 theta times the cosine of negative theta. But wait a minute, cosine is even. So I can essentially ignore that negative because a negative angle measure and a positive angle measure will give me the same ratio. Now, look up here and see, because order doesn't matter in addition. So if I had flipped that into the cosine of 7 theta plus the cosine of 5 theta, then I would have still had, add those two things together and get 12 theta all the way down. But look what would have happened if I had subtracted. I would have gotten 7 thetas minus 5 thetas is positive 2 thetas. Divided by 2 is a positive theta. So by applying an even-odd identity, I got the exact same answer. Okay, so let's do 3 more. Okay, so I've got the sine of 4 theta plus the sine of 6 theta. So again, I'm adding sines with different angles. So I'm going to use 2 sine alpha plus times the cosine of alpha minus. So here's my alpha, here's my beta. So what I end up with is 2 times the sine of alpha plus beta is going to be 4 thetas and 6 thetas is 10 thetas over 2 times the cosine of alpha minus beta. So that gives me a negative 2 theta over, over 2. I started to write a 0 and a theta at the same time. Okay, but again, I could have flip-flopped the order here and said sine 6 theta plus sine 4 theta and kind of avoided that negative issue, but I didn't, so now we got to deal with it. So that gives me the sine of 5 theta times 2, and then negative 2 thetas over 2 is a negative theta, but cosine is even, so I can essentially ignore that negative. All right, so we got 2 more. So I've got the cosine of theta over 2 times the, minus the cosine of 3 thetas over 2. And so my arguments are not the same, so I can't combine like terms, but I can find cosine minus cosine. So I will have negative 2 times the sine of alpha plus beta over 2 times the sine of alpha minus beta over 2. So this is my alpha, this is my beta. Lucky for us, we've already got common denominators. So I've got negative 2 times the sine of theta over 2 plus 3 theta over 2, all over 2, times the sine of theta over 2 minus theta over 2, all over 2. Okay, so what does that give me? I've got a negative 2 times the sine of 1 theta over 2 plus 3 thetas over 2 is 4 thetas over 2, which reduces to 2 theta. And then the sine of 1 theta over 2 minus 3 thetas over 2 is negative 2 thetas over 2, which is negative theta over 2. Okay, so sine is odd. That means if I change this, because he's positive right now, if I change this to a different sign, I got to change this to a different sign. So I'm going to go from negative to positive. So this means it's going to go from positive to change that. So it's a negative times a negative. So that gives me a positive 2 sine theta times the sine of positive theta over 2. And then the last one that we're going to do is going to take just a couple more minutes than these ones have done. But again, holy cow, we're knocking this out in one video. So I've got the sine of 2 theta, and I'm supposed to be solving this on one interval or one lap around the unit circle. So I got the sine of 2 theta minus the sine of 4 theta, and that needs to be 0. So I'm not going to go into double angle identities and all that kind of stuff. I could, but I'm not going to. Why? Because I know what sine alpha minus sine beta looks like. Okay, so I'm going to go ahead and apply this. So this is my alpha, and this is my beta. And as soon as your angle measures match, as soon as your arguments are the same, you can start working in algebra. So what I have right now is when I'm subtracting, I get 2 sine of alpha minus beta over 2 times the cosine of alpha plus beta over 2. And that's supposed to equal 0. So I have 2 sine of 2 thetas minus 4 thetas is negative 2 thetas over 2. And then I've got the cosine of 2 thetas plus 4 thetas. Oops, sorry, that's not a 3, is a 2. Okay, so again, sine is odd. So if I change this to a positive, I got to change this to a negative. So now I've got negative 2 sine of theta times the cosine of 3 theta. Okay, so what I've done, I was just yapping a while ago about if your arguments matched. Okay, well, that's if you've got addition subtraction. But look, I've got a -2 times sine times cosine is 0, which means each one of these needs to be set equal to 0. So I'm going to start off by dividing everything by -2, which is going to give me sine theta times cosine 3 theta is 0. And now I've got this factor times this factor is 0. So the sine of theta can be 0, or the cosine of 3 theta can be 0. So don't go and think you've got to go into adding and subtracting and all that kind of mess. You know how to do this because we did it way back in, I don't know, 8.2, 8.3, somewhere in there. So where does sine equal 0 in one lap of the unit circle? Sine equals 0 in one lap of the unit circle at 0 and at pi, but not at 2 pi because we're not including 2 pi. Okay, so where does cosine equal 0 in one lap of the unit circle? And this is where we're going to do several iterations. So I've got 3 theta equals, just tell me where cosine is 0. And that's going to happen at pi over 2 and again at 3 pi over 2. So from there, I need to add or subtract, not subtract, I need to add multiples of a lap. So I need to add 4 pi's over 2. So 4 pi's over 2 makes a lap. So I'm going to add pi over 2 and then take a lap. And then take a lap again. So I'm going to do this a couple of times. So I got a pi over 2 plus 4 pi's over 2 is 5 pi's over 2. Plus another pi over 2 is 9 pi's over 2. Okay. And then 3 pi's over 2 plus 4 pi over 2 is 7 pi's over 2. I don't know if you notice the little pattern here. Okay. But you're going in odd multiples of pi over 2. So I don't care what 3 theta is. I care what theta is. So I'm going to divide everything by 3, which means pi over 2 divided by 3 is going to be pi over 6. So all of your denominators are going to become 6's. So that's going to give me pi over 6. 3 pi over 6 is pi over 2. So he's a pi over 2. 5 pi over 6. 7 pi over 6. 9 pi over 6. Well, 9 pi over 6 is 3 pi over 2. And then 11 pi's over 6 takes you right smack up next to 12 pi's over 6, which is 2 pi. So those are all of your solutions. And that is section 8.7. So you are now ready for your chapter 8 test.